The shocking truth about the nature of consciousness. Most of us think of consciousness as a light that's either on or off. You wake up and the light is on. You go under anesthesia and the light goes off. Simple. The truth is far messier and more interesting. The light flickers, it spreads, it narrows, it moves around the brain, and sometimes it reports more than it actually sees. Today, you'll hear why your conscious mind is less a camera and more a newsroom, aggregating, editing, and broadcasting stories about what matters to you, often after the fact. 1. What scientists mean by consciousness. In research, consciousness usually means two things. First, level of consciousness. Awake, drowsy, dreaming, anesthetized, or in a disorder of consciousness. Second, content of consciousness. What you are actually aware of right now, like the color on the wall or the pressure of the chair against your back. This split matters because different brain systems seem to regulate level and content. A growing body of work argues that the content you experience depends largely on a posterior hot zone in the back of the cortex, while access and report depend more on frontal systems that help you share and act on what you experience. 2. The brain's newsroom, global workspace. Theory. One of the most tested ideas is the global workspace theory. Picture a newsroom at deadline. Many local desks process their own beats, but only a few stories make it to the front page where everyone can see them. In the brain, specialized modules process sights, sounds, words, and feelings in parallel. A piece of information becomes conscious when it wins a competition for attention and gets broadcast widely to other systems: memory, decision-making, language, motor control. You experience that broadcast as awareness. That is the core claim of the theory, and it predicts measurable ignition signatures in the brain when something crosses into awareness. 3. Arrival frame, integrated information theory. Another influential idea is integrated information theory, IIT. It starts from the inside out and asks, how much does a system both differentiate information and knit it together into a single whole? The more integrated and complex the causal structure, the richer the consciousness. IIT has inspired tools for probing consciousness in unresponsive patients, yet it's also controversial, with ongoing debate about whether its key quantity, phi, is uniquely defined or practically computable in real brains. 4. When theories face the data head-to-head. To move beyond arguments, researchers launched a multi-year, open, adversarial collaboration, testing the strongest predictions of the workspace and integration camps across large, pre-registered experiments. Early high-profile publications from this effort reported mixed outcomes, with some results favoring global broadcasting dynamics and others challenging specific integrated information predictions. The bigger picture is that our best theories now generate rival, testable forecasts, and the field is finally settling disagreements with large, transparent datasets, rather than intuition. 5. Measuring the light itself. If consciousness is a broadcast, can we measure whether the transmitter is on without asking the person to talk or press a button? One promising method uses a magnetic pulse to ping the cortex and records how complex the echo is across the brain. In healthy wakefulness, the echo is rich and differentiated. In deep sleep, general anesthesia, or some disorders of consciousness, it collapses into simpler patterns. This perturbational complexity index has been validated across patient groups and can help stratify unresponsive patients whose minds are otherwise silent to bedside exams. 6. The shock? You don't see reality, you predict it. Your brain is not a passive recorder. It's a prediction machine. It constantly guesses what's out there and updates those guesses with incoming signals. That's why change blindness is so common. Even large changes can go unnoticed if they don't hit your predictive spotlight. In classic studies, people often fail to notice when the person they are speaking to is swapped mid-conversation, because the brain's model predicts continuity and fills in the gaps. The point is not that perception is broken, it's that perception is efficient and biased toward what helps you act. 7. Your body image is a suggestion, not a fact. Hold a rubber hand where your own hand would be. If someone strokes both the fake hand and your hidden real hand in sync, many people begin to feel that the rubber hand is theirs. Vision plus touch fools the self-model. This rubber hand illusion shows how awareness of me is constructed, useful, and surprisingly flexible. 8. You can act on what you don't experience. In blindsight, people with damage to primary visual cortex report that they see nothing in part of their visual field, yet they can still point to moving objects or guess features better than chance. Behavior leaks through even when awareness is gone. This dissociation warns us that conscious vision and visually guided action are partly separable, and that the machinery for action can run without the feeling of seeing. 9. Where in the brain is consciousness? Lesion and imaging evidence points to a posterior cortical hot zone, parietal, occipital, and temporal areas, as critical for the contents of experience. Damage here erases pieces of the inner movie: color, faces, motion, even dream imagery. Frontal cortex is still important, especially for broadcasting, report, and control. But many current reviews place the minimal substrate for experience as such toward the back of the brain. The debate is active, and some studies find prefrontal contributions under specific tasks, but the weight of evidence has shifted toward a posterior emphasis for content. 10. Knobs that change conscious experience. Two natural knobs alter consciousness in opposite ways. General anesthetics tend to reduce the brain's integrated complexity and disconnect large-scale networks, which lines up with a drop in level and content. Classic psychedelics can do the reverse, loosening rigid network patterns and reducing the dominance of the default mode network, often correlating with ego dissolution and unusual sensory richness. Different mechanisms, different directions. One lesson: conscious style depends on network dynamics, not a single consciousness center. 11. A practical model of why it feels like something. One mechanistic proposal, the attention schema theory, says the brain builds a simplified internal model of its own attention to control it better. That model leaves out the gritty details and gets reported as an ineffable experience, which is why awareness feels like a non-physical glow, even though it's a useful sketch the brain uses to manage focus. This idea predicts dissociations between attention and awareness and offers testable handles for experiments. 12. Why reports are not the whole story. For decades, researchers asked people to press buttons or say what they saw. Helpful, but those actions add their own brain activity, which can contaminate the signal we're trying to isolate. No report paradigms try to infer seeing without asking for a report, for example by tracking reflexes or pupil changes. These methods reduce confounds, although critics argue they introduce new ones. The field is now combining both approaches to triangulate the true neural correlates of experience. 13. The predictive brain as a unifying thread. Step back, and many findings rhyme with predictive processing and the free energy principle. The brain minimizes surprise by updating internal models using sensory evidence. Consciousness may be the brain's way of surfacing model updates that matter for flexible behavior, social communication, and long-term learning. This is less a single theory of consciousness and more a framework that ties attention, expectation, and perception into one picture. 14. What this means for AI and everyday life. If consciousness depends on broadcast availability, richly integrated causal structure, and self-models of attention, then today's language models are impressive communicators but not obviously conscious. They can report anything we trained them to say, yet they lack a living body, unified sensoromotor loop, and persistent, self-maintaining dynamics. For everyday life, the shocking truth is gentler than it sounds. You and I live inside a useful story that the brain keeps updating. We miss changes because our models favor stability. We feel ownership over a rubber hand because our models favor coherence. We act on signals outside awareness because the system is optimized for survival first and storytelling second. 15. Closing takeaways. 1. Consciousness is not a switch. It's a dynamic broadcast with measurable signatures. 2. The contents of experience rely heavily on posterior cortex, while frontal systems help broadcast, control, and report. 3. Experiments that trick the self, change blindness, rubber hands, blind sight, reveal that awareness is a constructed model, not a raw feed. 4. Competing theories are being tested in open, adversarial collaborations, so we can finally converge on what the brain is doing when the light is on.